Hi, I'm Professor Doug Baird, and I want to talk to you about one of Liverpool's field projects that involves a significant component of experimental archaeology, which has really helped us with our understanding of a particular archaeological site. This is the Bunjuklu project, on which we're investigating the origins of sedentary behaviours, agriculture in central Anatolia. The site is only about 10 kilometres north of the famous World Heritage Site of Çatalhöyük. So along with understanding the beginnings of sedentary life and agriculture in that area, we're also interested in the antecedents of Çatalhöyük, and especially the development of households and ritual behaviour in the context of the emergence of sedentary communities. The Konya Plain, in which the site is located, is on the south-central part of the Anatolian Plateau, and the environment's a little bit different from the Fertile Crescent, where agriculture first emerged, and they were probably challenging in terms of living conditions, and that's again why we're quite interested in the affordances of the Neolithic structures and houses that were built there. So we undertook an experimental building and maintenance program to better understand the nature of the buildings and also the site formation processes in the open areas surrounding the buildings. Very particular questions were how robust these structures would be, questions about how the ventilation works, and there are also questions about how well insulated they'd be in the cold central Anatolian winters. We see all sorts of replacements of post holes. How did that work? Did the roof have to be modified each time posts were moved? We also observe a lot of features in the floors, and we presume might be drip marks, but we wanted to be able to observe that in practice. There are burials under the floors. People have wondered about, whether it would have been a smelly environment to live in. So it was going to help us in understanding what we observed in the excavation of the archaeological site. But in addition, we wanted to have a public engagement element. The archaeology at Bunjuklu is not the most eye-catching. The structures aren't particularly well preserved, and we wanted to allow visitors to the site to better understand the archaeology by observing some reconstructions. We reconstructed 4 Neolithic structures based very much on the archaeological record, and it turned out actually that the buildings have remained robust. We've had them up, at least 2 of them, for 7 years. So even though they appear fairly flimsy and they're only constructed of quite small mud bricks, one brick thick, they've held up well. Actually, it's the floors that proved the most difficult thing to replicate, and it took a lot of sourcing of very specific materials and a lot of careful working materials, including long periods of polishing. We also learned that the floors would take a long time to dry as well, so people probably had to vacate these buildings each time they replastered them for a week or 2 while the floors dried properly and then were polished to harden them and to give them a bright reflective surface. We learned a lot about the way to use fuel for the hearths in the buildings. Probably the hearths would be quite smoky when wood or dung was first lit. So we learned that the best thing was probably to light the fires outside the buildings and take in glowing embers for the hearth to cook over and keep the building warm. The ventilation system afforded by just having a smoke hole and a doorway was also not that effective, so we now speculate that they probably removed occasional mud bricks from the very top of the wall just under the eaves of the roof to allow ventilation, and we tried that and it worked very, very well. The little features we observed in the floors around the hearth were replicated in the experimental buildings, from the dripping of water along the edge of the smoke hole, so our speculations about that seem to have been very neatly demonstrated. In short, we found it very instructive in terms of understanding the archaeology and the nature of these structures and how they were used.
Hi, I'm Phoebe. I'm a third-year undergraduate student at the University of Liverpool. I am doing my dissertation research in our labs, and I'm looking at whether or not birch bark tar could be used to make clothes by Neanderthals. I wanted to look at this because I'm quite into making my own clothes, so I did a lot over lockdown. And I'm really into the Paleolithic, so I was thinking about ways that I could put the two together. And in a lot of the DIY videos that you see online, they use fabric glue if you don't have a sewing machine. So I was wondering if there's any kind of precedent in looking at early fabric glues. And I emailed my supervisor and he said that he wasn't aware of any, so here I am. And I have been testing over the last few days different recipes for birch bark tar. So you make the tar and then you can add in different inclusions such as wax, rosin and ash. And so I was trying different levels of that and found that the ash was by far the strongest. And now I'm just looking at whether altering the levels of ash will make it any stronger or any weaker. And then hopefully I'll be able to compare it to some modern baseline data of modern seams, and we can come to some conclusions about whether Neanderthals were likely to have done this kind of stuff.
I'm Larry Barham, Professor of African Archaeology at the University of Liverpool. And all of us interested in experimental archaeology understand its value for theory building and theory testing. Here at Liverpool, we have a broad international reach in our research, which allows us to add an additional component, and that's indigenous knowledge. For example, colleagues who are working in Turkey on ancient Neolithic hut structures benefit from current knowledge, contemporary knowledge on brick making and plastering the floors and walls. In my own research in Zambia and South Central Africa, I benefit greatly from talking to people who still make traditional axes and adzes like this one, and how they select the raw material, how they pierce it, and how it functions for particular tasks. And we've just begun in Zambia new projects with the Moto Moto Museum in northern Zambia to look at the ethnography of the last of the bark cloth makers. Bark is an important material in the tropics, not just in Africa, and I think it has a long antiquity. So we can benefit, I think, from contemporary bark cloth makers for understanding some tools of the later Stone Age, that is, in the last 10,000, 12,000 years in Zambia. But you don't need to look abroad for indigenous knowledge. For example, not far from where I live, there is a young man who is a fourth generation wheelwright. He makes wooden wheels. And his knowledge of local woods, their properties, and how to shape them, which ones to choose for hafting, is unparalleled. It's an unappreciated knowledge. So that's another benefit for just looking around and seeing who still makes things in a way that are pre-industrial. So think about experimental archaeology as something that's potentially all around us.